why the more distant galaxies are moving away faster.
The analogy that astronomers use, no analogy is perfect, right? We're dealing with things, not just in the 3 dimensions of space, but in the 4th dimension of what we call space-time. So we have to visualize things that are really unvisualizable by the human mind, by our own limitations. And so we make analogies. So one of the most common analogies is to think about, I'll give you 2. One is to imagine a balloon with little dots drawn on the balloon's surface. The balloon's surface is 2-dimensional. As you blow up the balloon, the galaxies move away, the dots on the balloon's surface move from one another, and they move with exactly that property, that a galaxy that is 1 centimeter or a dot that's 1 centimeter away from another galaxy or dot will move twice as much in the same amount of inflation or expansion as a galaxy that is half a centimeter separated, or 2 dots that are only 5 millimeters apart from one another. But that's confined to a 2-dimensional surface, so it's a little bit hard to maybe project that into 3 dimensions in our mind. So another one that people use is, imagine baking a raisin bread. So a bread, and you put in a bunch of raisins inside of it. That too has the exact same property. If you sit on any raisin inside the bread and you watch, what are the other raisins doing? They all will be observed to move away from you. There won't be any gravitational attraction between you and another raisin. So you'll actually observe what's like a perfect expansion of the universe from your perspective. Remember, I said there are about 20 or more galaxies that are gravitationally attracted to the Milky Way, and they are blue shifted because they're falling towards us and will eventually combine into an enormous mega galaxy called Milkdromeda someday. But that doesn't happen for raisins or for dots on a balloon. So the law that describes that type of expansion in either a raisin bread populated with raisins in 3 dimensions or a balloon dotted with magic marker marks in 2 dimensions, those 2 phenomena are exactly displaying what's called Hubble's law, which is the velocity of every galaxy we see beyond a certain distance. That's a minimal distance that we don't have gravitational interactions between us and them. That galaxy will be moving away directly proportional to what's known as Hubble's constant. So the velocity in meters per second, miles per hour, furlongs per decade, whatever you want, will be directly linear. It's the simplest law imaginable besides just a constant. It'll be moving linearly proportionate to its distance away from you. And that's a fascinating observation. And that's the only type of observation that can produce the type of structures that we see in the universe. In other words, it could have been traveling as the velocity scaling as the square of the distance, the cube of the distance, the square root of the distance, whatever. We would live in a much, much different universe, and it wouldn't have any of the characteristics that we observe.